See this question is again on multiplication theorem, where instead of having two events we are going to have more than two, that is three events here. Now the question is like this: suppose that each of three men at a party throws his hat into the center of the room. The hats are first mixed up and each man randomly selects a hat. What is the probability that all of the three men selects his own hat? B. None of the three men selects his own hat. So try to understand this question. Now there are three men and they are having hats. Now they will take out their hats and throw them into center of the room. Now in the center of the room they are all mixed up, and now these three men, without looking at the hat, they are supposed to pick the hats at random. Now what is the probability that all the three men selects his own hat? Now we should say with what probability that they select their own hats, and B is none of the three men selects his own hat. So how to solve this question is, let's do this way. Now let's define three events. Now E1 is the event that person number 1 selects his own hat, and E2 is the event that person number 2 selects his own hat. Similarly, E3 is the event that person number 3 selects his own hat. Now what can we do with these events? See, first one is how to frame the first question in terms of these events. All of the three men select his own hat, which means we are supposed to talk about probability that E1 first person selects his own hat, and second person selects his own hat, and third person selects his own hat, right? Now are they actually dependent events or independent events? How to know about it? Simple. Now we have this collection. Once the first one chooses one hat, then the other person getting his own hat depends on what he has chosen, when the first person has chosen, isn't it? Once a person has removed a hat, now the probability that the second one will get his hat will depend on what first one has chosen. Therefore they are all dependent, or you can even think of it as a problem in which there are no replacements. So whenever there are no replacements, the events are dependent, right? And so whenever the events are dependent, we have to apply the conditional probability, not the normal probabilities. If the events are independent, then we can apply the independent events and normal probabilities. For example, if the problem would have been, let's say three men are there and they have just thrown the, okay, we shall see the problem later about the independent events. I'll again frame the question, but for now let's try to focus here. Now what is that we want to find out? E1, which means the first person has to pick his own hat, and second person has to pick his own hat, and the third person has to pick his own hat, right? See this. Now we have already seen how to write this in multiplication theorem, or the chain rule. What is it? It is equal to probability that first person will pick his own hat, and then probability that second person will pick his own hat given that first person has picked his own hat, right? And then the probability that third person will pick his own hat given that first person and second person has picked up their own hats. Now let's try to analyze it. Now what is the probability that there are three hats? What is the probability that first person will pick his own hat? Out of three, there is only one is his hat, right? Therefore the probability is 1 by 3. Why 1 by 3? Because there are totally three hats, out of which only one is his hat. That is why it is 1 by 3 multiplied with, now once you have picked up one hat, the first one has picked up one hat, there will be only two hats remaining, out of which only one hat is for E2. Therefore the probability that the second person will pick his own hat given that the first person has already picked his own hat is 1 by 2, because there are only two hats, out of which only one hat is the right hat. Okay, now what about this one? This is interesting. See this. Now already first one has picked up his own hat, second one has picked up his own hat, then definitely only one hat is remaining, which is certainly the third person's hat. Therefore if E1 and E2 has happened, which means if first person and second person has already picked up their own hats, then with 100% certainty that third person will pick up his own hat. Therefore it is 1, which means 100%. Therefore what is the probability? 1 by 6. The probability that all the 3 will pick up the their own hats is 1 by 6. Now look at the second one. None of the 3 will pick up their own hat. This is all of them will pick up their own hat. The second one is none of the 3 will pick up their own hat. Now by looking at this, you might feel that these two are complements, and you might try to write, or you might want to write 1 minus okay, let's try to frame this in terms of this. This is A. Let's try to frame B. None of them picks up his own hat, which means E1 should not pick, E2 should not pick, E2 complement, and E3 should not pick, and all these 3 events should happen, which means what is the second question? E1 should not pick, and E2 should not pick, and E3 should not pick. You might feel that these two are complements, but actually they are not complements, isn't it? So in fact this one can be written as P of E1 union E2 union E3 complement, isn't it? Therefore these two are definitely not complements, isn't it? So the complement of this one is E1 union E2 union E3. Or if you want to understand the difference in basic terms, see here all the 3 have to pick their own hats. Here none of the 3 has to pick their own hats. Now what is the difference between two? Why can't I take the complement is this. So you cannot say that 1 minus all the 3 picks up their own hats is equal to all the 3 none of them pick their own hats. Actually none of them picks their own hats. Okay, let's see this one. What about the complement of this? It is a bit difficult to explain. Try to understand this. Now if I take the complement of this event, the event that all of the 3 men selects his own hat, if I take the complement of it, then it will contain various events. So what are they? Exactly one person picks up his own hat, and the 2 will not pick his own hat, and 2 people will pick his own hat, and 1 he will not pick, and then 3 people will not pick, all the 3 will not pick, which means if you take the complement of it, it is going to contain many cases. One case is exactly 1 picks right and 2 picks wrong, or 2 picks right and 1 picks wrong, and all the 3 picks wrong. That is why I cannot take the complement of this. I have to compute it separately. Now we can it is again looking like a intersection, and we might feel like applying the multiplication rule. Now let's see what happens if you apply the multiplication rule. P of E1 complement into P of E1 complement given E2 complement given E1 complement, and then P of E3 complement given E1 complement and E2 complement, which means the probability that first one does not pick the right hat, and then the probability that second one does not pick the right hat given that first one has not picked the right hat, right? Now let's see this. It is clear that probability that first one will not pick the right hat is definitely going to be 2 by 3. The reason is simple. There are 3 hats and 2 of them are wrong hats, and if he picks any one of these 2, then it means that he didn't pick the right hat. That is why probability that first one not picking the right hat is 2 by 3. Fine, I agree. Now what about the probability that second one will not pick the right hat given that first one has not picked the right hat? This is a different thing, or this is difficult to answer. The reason is, if first one has not picked up the right hat, then there are two cases. First one might have picked up the second one's hat. In that case, see, what I mean to say is, you have hat number 1, you have hat number 2, and you have hat number 3. Now first one does not pick the right hat means he will not pick this, but he might have picked any one of this. If he might have picked this second hat, then what are remaining? 1 and 3. Therefore the probability that E2 will definitely pick the wrong hat is going to be 1, it is certainly whatever he picks, it is going to be wrong. Or the other choice is, now the first one, instead of picking up the hat 2, if he has picked up 3 and he didn't pick up 1 and 2, then for the second one the hats remaining will be 1 and 2. In this case, the probability of picking up a wrong hat for the second one is again going to be 1 by 2. Therefore, if you try to analyze it using the multiplication theorem for this particular, for this type, it is difficult because this part is not clear. This part is not only depending on the number, it is also depending on what type of hat E1 has picked up. That is why instead of worrying about it, instead of evaluating this way, I'll take the other formula and evaluate it. See, if you can evaluate it using the first one, you can go ahead and do that, but then it is having too much complications, so I don't want to do it. I don't want to evaluate it using this. So that is why instead of writing the multiplication theorem directly here and evaluating it, I'll take this one. This one is looking somewhat better for me. So let me see how to do this. Now how can you write about this? This is equal to 1 minus probability of E1 union E2 union E3. So how can I write this? I have already given you this, right? So I have already explained you that probability of E complement is equal to 1 minus probability of E. Similarly, if you take this entire thing as one event, E1 union E2 union E3, then I can directly write like this. So in order to solve this question, I have to solve this one. In order to solve this, I have to solve this. Now I have to solve this part. What is it? P of E1 union E2 union E3. P of E1 union E2 union E3, right? So are they mutual exclusive events? Mutual exclusive means, will there be anything in an intersection, which means will there be a chance that both E1 and E2 will pick the same ball like this, or say pick the same hat like this? Can I say that E1 E2 E3 are like this, E1 E2 E3 are like this, or can I say that E1 E2 E3 are like this? What do you think is right? See, why should I worry about it? Yes, you should worry about it because based on what you think E1, E2 and E3 looks like, depending on that, this formula will vary. Probability of E1 union E2 union E3, based on how these two will be looking like, you have to apply the formula. In case if they are looking like this, then probability of E1 union E2 union E3 is directly probability of E1 plus probability of E2 plus probability of E3. In case if they are looking like this, then probability of E1 union E2 union E3 is, we have to add them, and when you are adding all of them, you might have added some of the parts 2 times, right? And therefore you are supposed to subtract them, right? So that is the reason you should be knowing how it looks like. So how to find it out? Depending on the nature of the question, you can find it out. See, now if E1 represents the event that person number 1 selects his own hat, and E2 represents the event that person number 2 selects his own hat, and E3 represents the event that person number 3 picks up his own hat, then what does this part represent? This particular part represents this part. This part represents the probability that both E1 and E2 will pick up their own hats. Is there a probability for that or not? Yes, it is definitely probable. It is probable that there is a chance that E1 and E2 will pick up his own hat. Similarly, will there be this event? Yes. What is this event? All the 3 will pick up his own hats, right? Their own hats, right? So definitely all the areas are possible. So now let's expand this formula, keeping in mind that all the areas are possible. Now what is that? P of E1 union, so union is nothing but plus. So I am just applying the formula from the set theory, right? P of E1 plus E2 plus E3 minus P of E1 E2, which means E1 intersection E2, minus P of E2 intersection E3 minus P of E1 intersection E3 plus P of E1 intersection E2 intersection E3, right? Yes. Now it will be easy for me. So what about P of E1? What is the probability of first person or one person, the first person picking up his own hat, 1 by 3. What about the probability of second person picking up his own hat? 1 by 3. Third person is 1 by 3, right? These things I know. Now only thing that I have to find out is P of E1 intersection E2, E2 intersection E3 and E3 intersection E2. These parts, these three parts I have to find out, and then this part I have to find out. I'll use the multiplication theorem. See this. Now the first one is P of E1 intersection E2. Now how can I write it? Probability that E1 and E2 will have taken the right one. So it is nothing but probability of E1 happening multiplied with probability of E2 happening given that E1 has already happened, which is nothing but, what is probability of E1 happening? What is probability of the first person picking up his own hat? 1 by 3. What is the probability of second person picking up his own hat given that first person has picked up his hat? It is nothing but 1 by 2. So which means 1 by 6. Similarly, you can find out E2 intersection E3. P of E2 intersection E3. Now we are not interested about the first one. So now what about the probability? Now assume that second person is picking up the first. So what about the probability that second person will pick up the hat? 1 by 3. And what about the probability that third person will pick up the hat, right hat, given that second person has picked up 1 by 2, which is 1 by 6. See, when we are talking about it, don't worry about the first person, he is out of the game. Now we have 3 hats and only these 2 people, that is how we got it. And similarly on the same grounds you will even get P of E1 intersection E3 is equal to 1 by 6, right? So in order to understand how these are possible, you might have to watch this video once and again, over and again. So please watch this concept in this video again and again till you understand this, okay? And the next one I have to find out is this one. So what is P of E1 intersection E2 intersection E3? P of E1 intersection E2 intersection E3. Person 1 first picks up, assume that, and then given that person 1 has picked up the correct one, what about person 2, right? So I think we have already found it out. P1 of E1 intersection E2 intersection E3 is 1 by 6. This one we have already found out, 1 by 6, right? So this part is 1 by 6, this part is 1 by 6, 1 by 6, 1 by 6, and this part is 1 by 6. Now if you substitute them, I think you are going to get 2 by 3. Therefore this factor is going to be 2 by 3. So this entire factor is going to be 2 by 3, right? Therefore what is the probability that none of them will pick up the right hat? It is 1 minus 2 by 3, which is 1 by 3. Therefore the answer for B is 1 by 3. Okay, so if you feel that I might have rushed up a bit in this question, you please watch it over and again and you try to analyze it yourself. You'll understand it, you'll definitely understand it, and it is very important that you understand this question. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply. And statement of purpose building. and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.